So we have a canal with a trapezoidal cross section, and we'll have water at a certain level. That certain level will be D for depth, and you'll have a width at the top and a width at the bottom. So we need to derive an expression for the hydraulic radius as a function of depth. And so hydraulic radius is equal to area over the wetted perimeter. So we need to find two variables in this question. So I'm going to start with the area. So the area of a trapezoid is just the average of the width of the top plus the width of the bottom. So we just average those, multiply that by D for the height. So we're given that the width at the top is 4 plus D over 4, so we're just going to substitute that in for the area. In doing that, we get 4 plus D over 4 plus WB, that parentheses, it's still over 2 multiplied by D. We can simplify this a little more. We'll get 2 plus D over 8 plus WB over 2. And all this is multiplied by D. And we can just multiply it again if we wanted to. So in the end we'll get D squared over 8 plus WBD over 2 plus 2D. So that is technically our area for the hydraulic radius. So we'll put it at the bottom for now. So hydraulic radius will be equal to D squared over, I already forgot it, D squared over 8 plus WB times this by D over 2 plus 2D. So now we need to find the wetted perimeter. And so the wetted perimeter is just these two sides plus the bottom half, or the bottom part of the cross section. So we'll put the width for the bottom already, but we need to find these two lengths right here. And so we can recognize that in order to get this length, we need to treat this area right here as a triangle. So the height would be D, and the width of this part would be the width of the top minus the width at the bottom divided by 2, since we're only focusing on this area right here. If we didn't divide it by 2, we'd be accounting for both sides. So we're going to divide that value by 2. So with it being a case of Pythagorean theorem, we need to have a square root in order to get the actual length of it. And so a squared in this case would be the width of the top, minus the width at the bottom, all that over 2 squared, and then b squared is just d squared, and this will give us our length of one side. But since we need both sides, we're going to multiply this by 2. Okay, so now we need to substitute in WT. So we got that 2 is going to be equal to 4 plus D over 4 minus WB over 2 squared plus D squared. This is going to be very difficult, or at least tedious to square. So we have 2 over d over 8 minus wb over 2 squared. Oh man, so we're going to square this. Need to multiply this by each other twice. Copy and paste. There's a lot of... we'll just put it there. Whoops. I am all over the place. Okay, so we have 2 times 2. 2 times 2 is 4. Times 2, 4. This would be d over 4. This would be minus wb. Next part right here is going to be d over 4 plus d squared over 64 minus wb d over 16. The third part, negative wb, negative wb minus wbd over 16, and then this would be plus wb over 4, wb squared. I just want to make sure if I get this right. So 4, this would be d over 4, this would be negative wb, yes. And then d over 4 plus d squared over 64 minus wbd over 16, yes. And then negative wb, yes. And then yes, yes, okay. This should be right. I just add like terms. I'm just gonna go in order. So we got 4. We have 2 negative WBs. Notice we have we have 2 WD4s, which will just be d over 2. We have negative 2 WBD over 16, which would be this, plus d squared over 64 plus WB squared over 4. And that will be the wetted perimeter, this whole thing. And so I have a feeling, hold on, I'm looking at this because I feel like we can like combine this shit. So I'm actually going to try to combine these values because we're trying to make this in terms of d as a function of depth. And so I'm looking at these two terms right here, probably combine those, and then these two terms, we combine those. These two, we cannot. Actually, we could combine this with this, but I'm just going to start off small. So 4 minus 2WB, that would be, we'll do 2 times the quantity of 2 minus WB. Actually, no, we'll try to combine it now. Okay. So I'm actually going to try to combine these terms together, at least some of them. So looking at these two, we try to combine these. So d over 2 plus, or minus WBD over 8. we can multiply this in order to get d over 8 minus wb d over 8. We can make this equal to a 1/8 fraction, then 4 minus wb, all this multiplied by d. So that gets rid of those two values. And I've noticed one right here. We have a wb squared over 4 minus 2wb and then plus 4. Actually, I don't think we can combine those. We might not be able to, but maybe we can. Not really sure how we would do this, but I don't know. I'd say we just leave it as is. So really, I only simplified these two values right here. So in combining all these into the wedded perimeter, oh my gosh, whoops. All these put into the wedded perimeter, we already have the area, and then all of this will be the wedded perimeter. So it would be what, like d squared over 64 plus wb squared over 4 then plus 4 minus 2wb plus quantity of 4 minus wb d over 8. So this function right here can serve as the expression for the hydraulic radius